All right, welcome to The Explainer. We're all pretty used to AI that's incredibly smart, right? But what if it could do more than just know things? What if it could actually learn and evolve all on its own? Well, today, we're diving into a paper that lays out a blueprint for exactly that, a totally new kind of AI that can genuinely get better over time.
And this idea from Darwin, it's really the key to everything we're talking about. It's not just about being the smartest. For AI, that means raw intelligence. Well, it's not the whole story. The real game changer, the next massive leap forward, is all about one thing: the ability to adapt.
Okay, so to really get why this is so important, let's first set the stage. We need to talk about the fundamental problem, kind of like a glass ceiling, that even our most powerful AI models are hitting today. Why do they even need to evolve?
So here's a good way to think about it. Today's big AI models, the LLMs we all use, they're like these brilliant, massive libraries. They're filled with practically all the knowledge in the world. But, and this is a huge but, they never get a new book. Ever. All that incredible knowledge is basically frozen in time, from the moment they were trained. It's totally static.
And that right there, that static nature, is the critical bottleneck. It's a real problem. Because when we want an AI to be more than just a chatbot, when we want it to be an agent that can actually do things in the real world, well, you see the issue. How is an agent supposed to operate in a world that's constantly changing if its own brain, its own knowledge, is stuck in the past? That's the glass ceiling we're talking about, and it's what researchers are trying to smash through.
So this is where it gets really, really interesting. Researchers are finding ways to break through that ceiling, and they're doing it with a totally new way of thinking, a new paradigm. They're calling it the self-evolving agent. So, what exactly is a self-evolving agent? Well, it's not just a tool you pick up and use. Think of it more like a dynamic, living system. Of course, it can reason and it can act, but the magic ingredient here is that it can actually learn from experience. It can use what happens to it to continually make itself better.
And this is a great way to visualize the whole journey. It's like a roadmap to the future of AI. On the left, you've got the static LLMs we have right now. Then you have foundation agents, which are a step up. They can use tools and plan things out. But the real game changer, the key piece of the puzzle, is that middle step, the self-evolving agent. This is what many people see as the critical bridge that could one day take us from the AI we have today all the way to the horizon of artificial superintelligence, or ASI.
Okay, so that's the big picture. But let's get into the nuts and bolts. How does an agent actually evolve? What does that even look like in practice?
Well, the paper gives us a fantastic framework to make this super concrete. It breaks down the entire idea of self-evolution into three really simple but really powerful questions. What evolves, when does it evolve, and how does it evolve?
So first up, what is it that can actually change and evolve? The paper points to four key things. First, the core model itself can be tweaked. Second, it can update its context, and this is stuff like its working memory or even its internal monologue. Third, it can learn to use new tools, or get this, even invent brand new ones from scratch. And finally, and this is pretty wild, it can actually change its own underlying architecture, kind of like rewiring how the different parts of its brain talk to each other.
All right, next question. When does all this evolution happen? The paper breaks it down into two key timings. The first is called intra-test-time. You can think of this as adapting during a task. It's like adjusting your strategy in the middle of a video game. The other is inter-test-time, and that's all about learning between tasks. So after the game is over, you review what happened to become a better player for every single match you play in the future.
And finally, the big one. How does it actually learn? There are three main methods here. The first is pretty straightforward. Learning from rewards. This is basically trial and error, getting positive feedback for good actions. Second is imitation, which is exactly what it sounds like. It learns by watching an expert and copying what they do. And the third is really cool. Population-based methods. This is literally like survival of the fittest, but for AI. You create a whole population of agents, and only the best performing ones get to survive and reproduce to create the next generation.
Okay, so we've got the what, the when, and the how. Now let's connect all these dots and see how this actually builds into real-world impact. What does the road ahead really look like for using incredibly adaptive systems?
And look, this isn't just some far-off theory. This stuff is actually happening right now. Take a look at an agent called Voyager. It was put into the game Minecraft, and it learned to invent its own tools to get better at the game, completely on its own. Or how about reflexation? This one is wild. It literally has an internal monologue to figure out what it did wrong on a task. Then it saves that lesson to its memory so it never makes the same mistake twice. That's evolution in action. And when you start thinking about the potential here, it's just staggering. I mean, think about software engineering. We're not just talking about a slightly better autocomplete. We're talking about an agent that can find a bug in the code, write the fix for it, and then test it to make sure it works, all by itself. Or what about personalized education? Imagine a tutor that evolves and adapts to a student's unique learning style in real time. Or in healthcare, an AI that can adapt its medical analysis based on the absolute latest clinical data, literally getting smarter with every new patient case.
But with all this new power comes a really big new challenge. How do you grade a student that's constantly learning and changing? It doesn't make sense to just measure its success on one single test. We need new ways to evaluate them. We need to measure their adaptivity. How quickly do they learn? Their retention. Do they actually remember what they learned yesterday? And maybe most importantly, their generalization. Can they take what they've learned and apply it to completely new problems they've never seen before?
And all of this, it brings us to a pretty profound final thought. As AI starts to evolve on its own, our entire relationship with technology is going to change, isn't it? We're shifting from being the architects of static, predictable tools to being more like gardeners or cultivators of dynamic learning intelligences. And that leaves us with this incredible and maybe a little unsettling question that you see here. If AI can rewrite its own code and improve itself, are we still the sole authors of our future?